The problem asks to show how equation 27.22 on page 831 can be used to find the electric field outside an infinite plane of charge. Equation 27.22 states E disk of Z equals eta, which is right here, which is the surface charge density, divided by 2 epsilon naught, all multiplied by 1 minus Z over square root Z squared plus R squared, for Z is greater than 0. So, moving away from the disk at distance, let's say Z is greater than R, the disk appears as a point charge Q in the distance, and the field of the disk should approach that of a point charge. If we let Z go towards infinity, Z squared plus R squared is going to just be about Z squared, because the R will be eliminated because Z is approaching infinity and is so large. So, E of the disk would be approaching 0. We don't want E of the disk to vanish, but we want Z to be very large in comparison to R. So, the first step here is we factor out Z squared out of the square root to give, right here, we get E disk of Z equals the surface charge density over 2 epsilon naught multiplied by 1 minus 1 over square root 1 plus R squared divided by Z squared. So now R squared over Z squared is less than 1 if Z is greater than R. So the second term in the square root brackets is of the form 1 plus x to the negative 1/2, where x is less than 1. So, by binomial approximation, we can simplify the expression in the square brackets right there. So, we simplify it to right here, which is 1 minus 1 over square root 1 plus r squared over z squared, which is then equal to 1 minus parentheses 1 plus r squared plus over z squared to the negative 1/2. And then that all equals 1 minus, in parentheses, 1 plus negative 1/2 r squared over z squared, and that whole thing equals r squared over 2z squared. So that's a good approximation when z is greater than r. So if we substitute this approximation into the first equation that we had there, we find that the electric field of the disk for z is greater than r is E disk of z is about surface charge density eta over 2 epsilon naught times r squared over 2z squared, which equals q over pi r squared over 4 epsilon naught multiplied by r squared over z squared, which equals 1 over 4 pi epsilon naught times q over z squared if z is greater than r, which proves that we can use the disk equation to find the electric field outside an infinite plane of charge. Thank you.